So we're going to talk about a migration to PostgreSQL, which is about the only situation when I agree to put my hands on MySQL or something else. And or where it's the only case when I'm happy to do so, really. When you have to do that, you really feel like helping people out, like out of MySQL, for example. And so here we go. So I will present the case where we did that. It was a Photolog. Maybe you've heard about it. We'll get back to that in a minute. We will see the former architecture they used and why we did change it. And it's not really technical matters that meant we needed to change. We will see the new architecture, what it looks like, and it was a somewhat special project about the migration itself, and we will see exactly why that's the case. So we will spend most of the time of this talk will be spent on that part, migrating the code, services, data, and yes, blobs. And that's about it. So let's get into it. So Photolog, it's all about sharing photos. It's been a huge success in South America. The reason why is that they used a really crappy design of a website at first. The advantage being that it's really easy to load. There were about no graphics, just a background color, the photo in the middle, and that's about it. And the photos are scaled down. So if you have a crappy internet connection, the site is really easy to use nonetheless. So apparently that's the reason why it's been a huge success in some countries. And at the time when I was asked to help for the migration, they had already 32 million users, 1 billion photos, and in average 10 comments per photo. So that's about between 6 and 7 terabytes of data to migrate out. And we had a funny deadline, which is that the head of the company did not want to continue paying the bills to the hosting facility. So we knew exactly when the electricity would be shut down. That's the deadline. So here is what it looked like before we got our hands into that. That were a Java shop. So they're using Tomcat, Java, and at the moment when we decided to switch them over something else, they were in about the middle of a complete rewrite of all the stuff from Java to Scala, because one of the main developers said, Scala is so much better, I love it. And so all the new code he wrote was in Scala, and he tried to migrate one after the other the Java components. As they were using MySQL, they needed 3 layers of cache in front of that. The thing is that when you want to show up a web page in the old Photolog architecture, you get to memcache. If the data is not there, you ask Tokyo Tyrant. The thing is that when memcache runs out of memory, you're oozed. So it replaces the old data. So when that happens, new data gets written to memcache, Tokyo Tyrant, Redis, and MySQL. Memcache is left to do his own business, so only the hotspot data is in there. So if it's not in memcache, you go look in Tokyo Tyrant because it's built to disk when there is not memory anymore. So you have a better chance to find the data in there. And after a while, they were thinking that Redis is more cool than Tyrant. So they switched over to Redis. So some of the data, you found it in Tokyo Tyrant, some of the other data in Redis. But there was no way to know that in advance, so they did both the lookups. And if the data was not in one of those cache, well, they considered it was not there. Sorry about that. So if the data is not in the cache, they won't query MySQL to get it at all. It's, they prefer showing an error in HTTP code rather than asking MySQL for fetching the data. That was the situation. And when they began to grow big, they wanted to be able to shard the data so that they could have a better load spread between nodes. And they did that manually by writing a JDBC pool system. And so the Java code knew, depending on the user ID, where to find the data. How to find the data is easy. You have a user ID that begins with either a letter or a number. So you have 36 shards. So if you want to spread the load, it's not great because you have a lot more users that their names will begin with an M rather than an underscore or a 0, you know. But that's what they did. And if you want to outgrow 36 shards, well, good luck now. And they constantly needed to have what they call a small card, which is really the really basic information you want to get about a user. So that information, which is always needed, was in a central database. So there you go with a really nice spot. So we had to change that, but why did we change? In the previous slide, you might have heard that I was not really fond of the architecture, but the reason we changed it is really loosely connected to that fact. So Fotolog has been hired by iMedia, and they wanted, rather than that, just to grow a user base, to make money out of it. And the previous architecture was running on more than 100 nodes, and some of them were really expensive, and they had a SAN and things like that, so it was too costly to be making revenue and not reliable enough. They needed a full-sized operation team to run the website, and that also was contributing to eating all the revenue. So it was decided we needed to get that cost really down. And also, after iMedia acquired Fotolog, the founders took the cash and went away. That's what part of the deal. That did not happen from one day to the next, but still did happen. And it happened due to the development teams, so that we didn't have, iMedia didn't have any way to get the full knowledge of the application. There had been an overlap a couple of months, or maybe more, but they didn't use it properly, so one day, oh, nobody's left anymore, so who knows how the application works? Yeah, hard question. So that's why we changed. And as it's a PostgreSQL shop, relying on it for a long time, it's been decided to try a PostgreSQL architecture. And they know that PostgreSQL helps keeping the cost really low. So we will see how we did manage that. The new architecture began quite simple and finished like this. So the first cache we have is Varnish. Maybe you know about it. Then we have, well, the new team is all PHP. There is no Java skills in there. So it did get to PHP. And upon time, some cache layers had been added because they were needed. So the basic site browsing you do in Fotolog is you have a photo, and you have some friends with other photos and comments, and you can click around to get to other photos. But you also have Bing indexes. And so The memcache layer is for hot data. The Redis layer is for directories, indexes, like by country, by region, by date, extra, extra. And Memba stuff is for another kind of geographic cache. So this time it's, well, maybe it's about the same kind of caching that before, but this time we know about it. That's the difference, the main difference. And then we will spend some more time on the blue level. So on the web front ends, we have a PostgreSQL running. It's called the proxy, and it's running PL proxy. So some of you have been using PL proxy before? Yeah, okay, not many, but we will expand a little on that. And to do the sharding, we are using pghashlib, which is providing us with stable hashing functions. Again, we will have an example. So that was the front end, and now the back ends, where lies the data. We have, so didn't mention pgbouncer. So pgbouncer is on the web front, and it's talking to pgbouncer on the data nodes. And behind that, we have PostgreSQL, where the real data lies in, and pgq, so that we can organize the batch processing. And Wally is an archive tool from Heroku that allows you to archive the Xlog files to S3. So if you're running on Amazon, it's you have to consider Wally, basically. And well, so we will see after that the new hosting is all into an Amazon. So PL proxy, this little thing is quite awesome. The idea is simple. Each time you run a stored procedure, PL proxy is able to hash some of the parameters and send the query to another location. It's a remote procedure call, basically. So you call a function locally, and it will execute on this remote place. And which remote place depends on which ID you're using. So you can see here, we're using that cluster, and we're running on that shard, that partition. And the partition is the number is the result of using the hash string function. So PL proxy is great for that, because on each node you will have a full schema of your data, but with only a part of the overall data, the data that will be of use for a set of users. So if you have an obvious key to partition your schema, PL proxy is just great. The other thing about PL proxy is that it forces you down to be using procedure calls. You cannot just embed random SQL into your code and call it a day. You have to tweak the application to be running all the SQL via PL functions. In our case, it was not much of a problem, because as I said before, the PHP team was gone. The Java team was gone, and the PHP team was taking over the project. So they did want a complete rewrite in PHP. I'm not saying that's the best idea in the world if you want to migrate your application. I'm just saying that given the constraint we had, that was the best we could do. So we did it that way. And as the code got completely rewritten, switching over from embedded SQL to calling functions was not an additional cost. It was part of the deal, and it was the same cost as doing the SQL in the code as you most often do. And so about the hosting, it was a really expensive hosting we get before, but it was kind of hard to know how much of the 120 or 30 machines they had, how much that they really used. So we had to decide on a plan that allowed us to scale up if needed. So what we did is on the database server side of things, we did the setup 256 partitions into 16 servers. So each server is running 16 different databases. If that happens not to be enough, it's easy to get another bunch of 16 servers and migrate 8 databases per server. But if you want to rehash the data, you're getting into trouble. So that's the way we found not to have to rehash the data at the first scale opportunity. And those servers are running on classic entry-level Amazon web servers. Well, the database server a little more than that because we need more RAM. And Heroku is doing all the data storing into EBS directly, and they use that as a red array. Here we are doing, we're going with instances with local disks because it's less expensive. But that's about it. If you're into performances into Amazon hosting, that's not the best you can do. If you want to have a really tight controlled budget, that's a good option. So really the name of the game was to raise the revenue of the website. So the compromise is not the best performance you can get, but the best you can get with the smallest budget available, which is, I guess, a constraint you often reach. So we had 16 web servers, 16 database server, and then we had in 2 more servers for centralized things, like running the cron servers, the PGQs, things like that. And then you want to back up the thing. If you want to reach some level of availability, what you do is duplicate all the database servers, and you run a not standby per production server. That would be the basic step. But if you don't want to spend that many money on Amazon, what you can do is have a single backup server that is a not standby at each and every production server. So the good thing about it is that with only one storage node, you get a full backup of all the production nodes. The bad thing is that if a production node went to fail, then you have to copy the data to a new node and run it again. And in this case, it's taking like 6 hours to do so. So the compromise is small budget, so we are able to accept a 6 hours downtime if it goes really bad. It's been in production for a year now, and it's not going bad. We didn't have to do it at all, so it's okay. But the day we have to do that, we have a 6 hours downtime for sure. But on one node, so that concerns only a 16th of the users. So that's the compromise that has been done here. And the first thing we had to change after having done that is grow the EBS from half a terabyte to a full terabyte. And in Amazon, it's quite complex to do so. They offer tools, but if you use their tools, you will have so big a slowdown on the production machines that you don't want to do that, so you don't use snapshots. I'm sorry about that. Should be maybe quicker. So that was about the code and the hosting. Let's go to the services. The good thing about this low-budget migration was that we were able to go straight to a completely new hosting facility. So that means we don't have to do the migration on the same machine as the before architecture. You know, the MySQL host won't be transformed into PostgreSQL host. We have new machines for that. So we only transfer the data. It's much easier. So if you have the opportunity to do that, always do that first. If If you really want to reuse the same machines, it's more complicated to do so. So we have 6 terabytes of data to move over an internet link, because we are going from a hosted facility to Amazon, so it's the internet over there. We tried streaming the data with the MySQL foreign data wrapper. How many of you know about that thing? Foreign data wrappers for MySQL. Basically, it's an embedded driver. So what you do is you create a foreign server on the foreign table, and you tell to PostgreSQL, whenever I run a query against that table, the data is located on a remote server. So please connect to it. Use the MySQL API, like if you were a MySQL application client. Get the data from the connection and show it to me as if it were in a local database PostgreSQL data table. So I did try somewhat hard to get it working, because it's really awesome. You do insert into local table, select star from foreign table, and there you go. It's all done. So I was quite excited to get that working, but unfortunately it didn't go very well, because I don't know why, but the MySQL C API that I could read documentation about, I couldn't obtain from it any kind of performance. It was really slow, like in the kilobits range of speed. And we have 6 terabytes. We don't have 6 months. We have 6 weeks. So it was just not possible. So I tried to optimize that thing reading the MySQL docs. I hope you don't have to read the MySQL docs every so often. It's kind of crazy. Then I switched to reading the MySQL client code. It's even worse. So yes. So back to the basics. How do you move data around? Well, you run a SQL query against MySQL. MySQL will spit out some data, and you load them into PostgreSQL with a PSQL client. So if you read the man patch, MySQL will tell you, okay, if you pipe the data out to another command, the MySQL client is sending you CSV. Oh, that's really good. Let's do that. Okay. They are not escaping the separator field when it appears in the fields. Okay, why do they call that CSV? I have no idea. So we wrote a really simple client in Python to do that for us. It's like 50 lines of code. It's nothing. It's on GitHub if you think you need that. So consider it if you need it. And we had to use pgloader because we're getting there. It's not just data into MySQL. They don't put the same meaning in data as we do in PostgreSQL. So we will see some examples. So it appears to be a simple graph here, a simple schema of what's happening. You have the data on the red spot, which is MySQL. You run this query tool that will output real CSV that you are able to load. And with pgloader, you load it on a PostgreSQL instance. And then when it's there, you can message the data, copy it out, and spread it over to all the shards you want to target. So it appears to be quite simple. You have to remember that we're talking about 37 different MySQL sources. So the red box in there are 37 of them. We have some problems with encodings and data types, extra. So the best move we could do is load it all as text. So in the loading PostgreSQL instance, we have made a special schema with all the right column name fields, but it's all text. So then we can act upon it. And so then the copy from the PostgreSQL loading instance to the nodes is done via some SQL queries that will massage the data. It's like if you have done ETL before, it's the T step. So I like the T step being written in SQL because it's near to the data and you're massaging data. It makes sense for me. And with coalesce and some other transformation steps, you can get rid of like, 000-00-00. Nobody knows what it is, but MySQL says it's a dat. That's a date? Yeah, when did it happen? Yeah, basically never. It does not exist. But MySQL is really happy to handle that to PostgreSQL. And PostgreSQL is like, hey, what do you want me to do with that? So you tell PostgreSQL it's text, and then you run some queries so that it's date again. Oh, yeah. So dates are fun, but not as fun as blobs. So everybody knows what a blob is. It's binary data that you put into your database as is. The guys at Photolog had hard problem to solve with MySQL. So maybe they didn't have the right skill set to be able to address them with MySQL, and they did prefer to address them within the Java side of things, where they did have skills. Or maybe you can't do it properly with MySQL. This I don't know, and I won't enter that debate. But they did it that way. They partitioned the main guestbook. So remember, the guestbook table, that's where you have 10 billions of entries. And at first, they did it in a relational way, so they had multiple fields. And they finally realized that they are only loading all the comments that goes with the currently displayed image. So you don't need to be able you don't have to do any joins. So all you care about is the photo ID. The rest of the data, you can put that in a blob and don't ask MySQL to process it. You ask MySQL to store it and to retrieve it, and that's it. And for the data format of the blob, they found out that there is this thing called Google Protocol buffers, and they were really happy about it. And the Google Protocol buffer is given with Java, C++, and Python support. So I did try. The transform step is written in SQL. So if you can embed Python into SQL, it's called PL Python. So you write a Python function, and you can select star from the function, and it will return you several fields with the content of the blob decrypted. The problem is the blobs they had in MySQL were not using all the same encoding. There you go. So it was hard to do the proper thing in PL Python. It was easier in PL Java. Yeah, easier in Java. Yeah. There you go. The thing is that the previous, all the blob processing they did before was written in Java. So when I reached the first roadblocks in Python, I was like, okay, I will not try to second guess their Java system in Python. What about loading the Java system, the legacy one, into the transformation step? So you get basically the jar file from their old infrastructure. You put that into PostgreSQL, and you process the data with that. And that works. So that's how you do PL Java in PostgreSQL. So you declare the type of the data you want out of the blob. So here, for example, for a message, we have is it private, the parent ID, a message, and a username. So that's what you find within the binary blob if you look into it with the right tools. And then you can create a function that will use your jar file and get into com.photolog.blob.guestbook.getMessage. That's a function. Guestbook is a class. The other part of the thing is how do you get to the class? So it's a path entry. And each time we will call the function, it will execute the legacy Java code and get you the data back. It's, yeah? PL Java is only returning Unicode. And Java only works in UTF-16. So I don't know how the PL Python stuff got confused. But when you get to Java, it considers it's all UTF-16, transform it to UTF-8, and then handle it back to the database. So that got rid of the encoding problems. And then maybe some comments were having strange characters now that they didn't have before. But nobody went through the 10 billion lines to know about that. You know. Yeah, the main asset of the site is the comments, because what people love in Photolog is that they publish a photo. It used to be you're granted to publish one photo a day, and that's it. So once you've published a photo, what can you do? You comment on other guys' photos, right? So you publish whatever photo you want to, and you get at least 10 comments out of it. So people were really happy. Look, I have my photo, and everybody's looking at it. It's like, yeah, I'm famous. So they did that good. So the main asset of the website was those messages that we couldn't get out of the blob at first. So yes, we had to resort to PL Java. Okay, that's the main asset, we do that. So here is what it looks in the Java side. In fact, you import the legacy application packages, and you wrap them in a Java function to do the, you have like a layer in between the legacy code in Java and the PL PostgreSQL view of the world. So you have to get them to agree. And so the blob you see is, you get it straight from a database row, and the results receiver is the same kind of object as in a JDBC. And so you prepare your object this way. So using the Google Protocol Buffer API, that's the entire code I needed to decode the message. That's it. So it's not that bad. I didn't want to go this way at first, but it really was worth it. So that concludes the migration we had to do. So we migrated the code by rewriting it, the services by hosting them in a new place, the data with the old tricks with pgloader and custom SQL ETL kind of thing, because we needed so many different messaging of the data. And then we also had to migrate the blobs, and we did that with PL Java. So that was all the difficulties we had in that migration, in the database part of the migration. Once in production, of course, you want the users to continue using your website, and the indicators of the success of this site are the new users a day, new friends, new photos, etc. So the website has been really lively even after the migration. We did have two big problems which were quite funny. The first one is they messed up with the DNS settings, and so we lost like a third of our visiting users, and everybody was like, oh, they don't like the new design, because of course, if you rewrite all the shit in PHP rather than Java, you have user interface changes too, because the developers are like, it's too crappy, I can't reproduce that, I will do something better. It always happens. So they were like, oh, maybe they don't like the new UI, maybe we need to tweak it extra. And within 2 weeks, they were like, oh, we did it wrong with the DNS. They fixed that, and all the users were back in. So all the users, that means at any time of the day on this website, you have 9,000 users browsing. So when we just did the migration, we were down to 6,000, and people were really unhappy. And I was like, yeah, 6,000, you know. And we didn't know how to scale it properly beforehand, and it's running, so maybe it's not that bad. So yes, and they're still posting photos and comments, so that's pretty good. So we're using PGQ. PGQ, how many of you have heard about PGQ before? Okay, you're the usual suspect. PGQ is a queue mechanism embedded into PostgreSQL. So if you want to do queue tables, like you have events, you push them into a queue and you want to process them later, not while the guy is waiting on the web browser to finish processing the page, you know, so you just say, do that later. You register the event into PGQ, and you have a batch processing daemon that will fetch the events in the database in an efficient way and process them. And what we see here is the average lag of, so how many times is the processing of the event past the introduction of a new event. And in average, you have 20 seconds depending on the workers. You can see that in the but last column. And that's because the PHP daemons are set up to have a 20-second nap each time there is no event to process. So that's something you can set up. And what you can see, which is pretty interesting, is that we're using the new PGQ, PGQ3. So we can have what they call cooperative consuming. The classical model for PGQ is replication. So if you have multiple consumers, that means you have multiple replication targets. So each and every of them will process the exact same set of events. If you're replicating to several standbys, that's exactly what you want. If you want to spread the load of processing the events, that's exactly what you don't want, right? So they have cooperative processing, which means you can register as many workers as you want, and they will each get a different batch of events to process. So you can spread the load. And for all the different things we have to do when a new photo is inserted, like populate the caches, renew the per country indexes, per city indexes, extra. We do that in the PGQ, and a single PGQ processing consumer was not powerful enough to sustain the load. We had to run 4 of them in parallel. And so who's using PGBootser in production already? Okay. Thanks, Steven. I'm happy you came. Yeah. PGBootser is great. It's a little proxy. You tell your application to connect to PGBootser, and PGBootser will connect to PostgreSQL on behalf of the application. And if you're in transaction pooling mode, that means that when you connect to PostgreSQL, you get a session. Within that session, you can do transactions. PGBootser will keep its session open and accept transactions from any part of your application. So that you can have many sessions in between the application and PGBootser, but a few sessions between PGBootser and PostgreSQL. So here we are seeing a typical, I think it's a proxy instance, where you can see all the web pages are connected to PGBootser. So you have those numbers per node. And here is the same PGBootser, but with the backend view. So in the front end, you can see on the next to last column, the average column, you can see 447 clients are, in average, are connected. So I put that number up there again. And you can compare that to again, the average column is the next before last. And in green, it's the active backend connection. We have the whole 4 of them. So there you go. If you want to scale out and you have loads of application threads and you want to reduce the number of backends you want to have on PostgreSQL, PGBootser is great.
Is that for one of your 16 jars?
Yes, we will see We will see some more just after that. And pgboons are, yes, sorry. If pgboons goes down on a web server, we say the web server is fucked and we start a new one. Yeah. That's, yeah. But if Apache goes down on the web server, you do the same thing.
You had said that you have that one backup server which is doing hot standby for everybody.
Yeah.
Right? But you were saying that if a shard went out, you were going to have to wait 6 hours to copy up data somewhere else. Have you considered just promoting the backup servers?
Yeah, but where are you backing up the other 15 servers?
Well, I assume they're separate clusters, right? So you could
Yes.
still be backing them all up to that same box.
But that won't sustain the load.
Okay, and the box will get too busy then?
Exactly. It's quite busy already just doing the standby.
Yeah, I would guess it'd be pretty busy already.
It's doing like 150 megabytes per second of I/O, of writing I/O over to EBS.
Right. Well, yeah.
So you don't want to have to add to that the reads.
Right. It's just fun. I mean,
Yeah, it's a good sort. If you,
6 hours of downtime, like,
yeah, nobody likes that.
yeah.
Yeah, but it's again, it's all to do with the budget you can put in. So if you can put, for example, a red array of 10 EBS behind the backup server, then you can do that.
Couldn't you spin up a new Amazon instance and just move the one EBS connection for the down shard over to it?
Yes, but the new instance,
You have to redo the backup.
yeah, the new instance, we do that. You set up a new DB instance, and you tell it, grab the latest BAS backup we have, and then apply the wall. And grabbing the latest BAS backup from S3 is taking 5 hours, about. Because, yeah, I thought too. We've been trying some things, and we couldn't get past that 5 hours limit. So if you have more money to put in the program, you have a standby per production node, and the program disappears because it's ready. And it can accept the load because it's not doing anything else. And if you want high availability of both data and services, then you get 2 standbys per production node, and there you go. But, well, if you have the money to do that, you don't have that kind of programs. Yes? I'm sorry, I'm not hearing you. What was the worst problem we had?
He's asking about stored procedures inside of MySQL.
We didn't have any.
Yeah.
They were Java guys. They wanted to do all the stuff in Java in the application layer.
It's all front end.
Yeah.
It wasn't that.
The dumbest the MySQL was, the happier they were. So
Have you moved, has any of that changed beyond using DL proxy? Are you actually doing, is there anything, other stored procedures now?
it's all stored procedures now.
But I mean, but beyond just DL proxy part?
Yes, beyond. For example, the PGQ processing steps are all done in stored procedures too, because we packaged all those stored procedure into extensions, and we have been doing automated Debian packaging of those. So it's easier to, because, so you have all this procedural code running in your 16 database server. You have to remember it's 16 servers, but 256 databases. So you have to run 16 apt-get update, apt-get install, so you have the new version available, and then 256 alter extension update. So you want some kind of automatization in there. And so it was some amount of work to get there, but once you're there, it's all procedure, stored procedure, and it's all packaged, and it's all automatic. And even the developer, the PHP guys, at the end, found that comfortable enough. They didn't want to get back to embedding the code in the PHP, you know.
Are you using anything like PFSN or Puppet or
not yet. The admin guys running the systems are not comfortable with that kind of tools. So you have also to note that the whole migration we're talking about took less than 6 months. So yeah, adding Chef and Puppet that we didn't know about yet, it was out of the schedule.
It helps. I mean, if you're building out 16 identical systems.
Yeah, it should help. Yeah. Yes? I'm not sure about that. For me, XC is a different use case. But we will have several talks about XC in the conference.
Yeah, there will be just came from one actually.
Okay. So the hard part about the hard part about what we did here is to spread out the rights.
You can do that with PostgreSQL can do that. The one thing that you don't have to deal with this solution though is the TTL.
Yeah.
Right? I mean so you don't have one of those here. You don't have to worry about that. So that's kind of a nicety, but I think it'd be an interesting project to try to do something like this with XC.
And we did that last September, and there was no stable release of XC to try yet. Yeah.
Oh, sure. That doesn't change with this, though. I mean, if you lose a node with this, you have similar issues.
Yeah.
I don't know.
What we do here is, if we lose a database node here, we will reload the pgbouncer setups to remove the target partitions. And the PHP code is prepared when he runs a query to get this database does not exist error back from pgbouncer. So you get a nice error management for the user, which says, please come back later. Well, we don't tell them it's 6 hours later, but that's part of the deal, right? But you can still browse and see all your friends' photos, because mostly your friends' photos are on other shards. And if you're lucky enough, those other shards have not been getting down. So it's only a 16th of the site that is down when you lose a node.
Yeah, I think the PGXC could do that too.
Yeah.
Although, I heard in the prior talk, one of the difficulties would be when you actually want to bring that node back in, you have to like restart the cluster.
Oh, nice. Yeah.
Right, that's coming, but not there yet, right?
Yeah.
Eventually.
Here in that case, to get back the cluster back in.
You just have to reload the PG.
Exactly, and that's it. So even for some maintenance operation, we do that. Some maintenance, we know it will disrupt bad enough the production performances that we prefer to bring down the target just by removing, by commenting a line on the pgbouncer setup. We do our stuff, and then we bring it back on again. And usually it's more efficient this way because users are opening less support ticket than if we try to do it online. For some stuff that are to do online. We have query speed. We have on the DB nodes. That's the number of transactions per second we had when we launched the website. So it's per DB node. So it's easy. It's a load that's easy to handle, and we have 16 of those, which means the scaling is about right for the use case currently. So that was a good surprise. We didn't need to scale up the cluster first thing when running live.
So do you have you used the capability in Union to actually do like a stacked graph of all 16?
Yeah, but it's not readable. I can't read it. It's too many things. My eyes are not scaling.
At least see kind of the total.
We had some nice problems though with that kind of graphs, which is that we have too many things to graph, and we cannot use the standard PGBouncer, not PGBouncer, PGQ plugins. So if I get back here, I'm not sure about this one, but we have had to do some specialized main plugins to get all the data back to a single graph, because it won't be able to scale to that many graphs. It will spend 10 minutes each 5 minutes to update the graphs. Okay. No, not yet. Oh yes, we are doing. Yeah. So yes, we are doing that, but still. And the last graph here was the buffer cache, which looks like about right, but in fact there is a problem. The green line is so far away from the blue line that you think it's almost zero, but it's not. So what happens in fact is that we, for budget reason again, we only have 15 gigabytes of memory per backend node, per database. And that's not enough to keep all the indexes in memory. Yeah. So there is some pressure on the system to read data from the disk rather than the index. So we have some slow queries now and then, but it's been voted by the guys who want the money back that it's okay. We prefer to get some more money out of the website rather than having all of the users happy. It's not happening for every user. You know, it's one query out of 1,000, 10,000. So where you're at the engineering side, you're like, we have a problem, we want to solve it, and they're like, we want to make money, we don't want you to solve it. Oh, okay. So, but we know what the solution will be. You throw in some more RAM, and off you go. So.
Have you considered how that, you talked earlier about the trade-off between Amazon Web Services versus your own gear.
Yeah.
Whereas with Amazon Web Services, if you want to add that RAM, it's ongoing expense.
Yes.
Versus if you just go out and buy a bunch more RAM, it's cheap.
In fact, this hosting should probably go to our own gear now. Now that we know what to expect and how to manage it, we don't need Amazon anymore.
Yeah.
But for the launch, yeah, they're not cheap. But we had a really limited amount of time to solve all those problems, and we didn't want to spend so many times on the hosting facility side of things. We wanted to be able, on the network and etc. We did really want to have the migration done before they cut the electricity in the old data center. That was really important. So we figured out, let's go to Amazon. We're going there. It's flexible enough. If we don't get the right setup from the beginning, it's easy to click and change. And while doing the migration, we lost a number of nodes. While doing the data migration, we have 37 sources, so we had 37 database data loading nodes, and then we crashed them out, extra. It was really flexible. So for the first maybe 6 months or maybe the first year of hosting, it was really worth the money. But after that, yes, in the long run, you don't want to stay there. It's too expensive, and we are not benefiting from the facilities of like adding up web servers when there is a peak load and then removing them, because all the load is spread. So when do you remove and add servers? It's pretty flat. So yes, that service would be better hosted the old way.
Do you do any spreading, like through different Amazon data centers, or is it all just in one?
Just in one, because it costs less.
Okay.
All done to the same problem. The guys wanted the money back. They spent 65 millions of euros to get Photolog. So they want the beast to get the money back. Yeah. Yeah. Sorry? So we have 16 and 16, that's 32. The central admin database, 33. The central cron job database, so 34. And then we have 2 Redis nodes. And Membas is running on the web nodes, so that's not adding to it. And Memcache, it's the Memcache service by Amazon, so it's not instances. But you still have to pay about the same price as if it were instances. So it's 35, 36 servers now. Yeah, but it's so much less expensive than before. We had in a classic hosting facility 150 servers plus a SAN, and it was hosted in America where electricity is more expensive. Photolog was hosted in Equinix, New York. Yeah. So, yeah. Yes. So Memcache is the main cache of the website, but we have also some added data like geography extra that won't stay in the cache because we only have like 32 gigabytes of it. And we use Membase because we can run it on each and every web servers. The web servers were having like 2 gigs of memory free. And we are using that memory with Membase, and we have 16 per times 2, so that's 32 gigabytes of memory we didn't use. With Membase, we are getting to use it. It's less expensive than buying another Membase node. You know, you just get the most out of the web servers this way. It's all these projects is down to getting more money out of it. So you squash the thing. Yeah. Because when you, I would have to ask the guy now, I think we don't use Memcache anymore. We got from Memcache to Redis because when you lose a Memcache node and it starts again, it starts empty. And so you lose all the caching. And so the website, you need to load the cache, and the performance is bad while you do that. With Redis, you have snapshots, and when it brings back the service, you get the last snapshot worth of data into it, and it's much better on the thing. So I guess we know don't use Memcache anymore, but I should ring the guy to be sure. More question? No? Thank you very much.